Good afternoon, good morning to those from the Midwest or from the West Coast, and I see we have a couple of participants from Europe, so good evening. Thanks for taking time out of your schedule to join us for this discussion and presentation by the Aluminum Association on the 2015 Ducker Worldwide Automotive Survey. As you can see on the cover page here, the survey is a survey of automakers conducted by Ducker and confirms in a very exciting way the future of trucks, SUVs, and sedans will become lighter, safer, more fuel efficient while maintaining size, which is something that the industry and the aluminum industry is happy to support. We'll be presenting this as part of the Aluminum Transportation Group, the subcommittee associated with the Aluminum Association, and all information on this presentation will be further available at drivealuminum.org. Before we get started into the presentation, I'd like to take a minute to introduce the members of the Aluminum Transportation Group. And this group of participants into the Aluminum Transportation Group has been very beneficial in driving the progress that we've seen in the aluminum industry for quite some time. Alcoa, Kaiser, Novelis, Aluminum Precision Products, Alaris, Hydro, Rio Tinto Alcan, Penex, Sapa are all key members of the Aluminum Transportation Group and have had very active participation in meeting the challenges at almost every turn to get us to where we are today. As you'll quickly find, the information from this study is very exciting. It really is at a crossroads, an inflection point, to where we're going to see even quicker growth for aluminum consumption for years to come. And it's a result of tireless work from professionals from each one of these companies working to address the many issues that have faced us in the automotive world. As by way of introductions, you're going to have two primary presenters today. Myself, I'm Tom Boney. I'm honored to be the chairman of the Aluminum Association's Transportation Group. I'm also, for my day job, the vice president and general manager of Automotive Novelis North America. I'm very pleased to introduce a colleague of mine in the industry, a gentleman who has worked for many years in the automotive segment and will be presenting the majority of this technical paper, Doug Richmond. Doug is the technical committee chairman of the Aluminum Associations Group, and he presently also serves as the vice president of engineering and technology for Kaiser Aluminum. So with that, I'm going to turn this over to Doug. And Doug, please take it from here. Thank you.
Well, thank you, Tom. And audience, thank you for joining us today. I thought before we jump into this, I would introduce who Ducker Worldwide is so you get a sense of the organization that's behind the work that we're going to be talking about today. And this is actually the seventh study of this type that the Aluminum Association has commissioned with Ducker over the past 21 years. We do this every 3 years. And Ducker has been in the business of market intelligence and market research for over 50 years. And one of their areas of specialization is, in fact, automotive OEM and aftermarket products and product trends. And in fact, on this call today, we have with us, we're fortunate to have Dick Schultz, who has been managing director of Ducker Worldwide for several years. In fact, Dick was the lead researcher for all of the 7 projects we've done with Ducker, or at least been involved in them. And he, in fact, was the lead researcher on this 7th study. Dick recently retired from Ducker, but he's agreed to join us today in case there are any specific questions about Ducker or the methodology they used in this research. Now, just to give you a sense of the order of the discussion today, we talked a little bit about Ducker Worldwide, and I'm going to first give an overview of the growth that we're seeing from 2015 to 2025, and kind of a macro level overview. And then we'll jump into some detailed evaluations of what we regard as the major emerging market. And we are, as Tom said, at a fairly significant inflection point in the use of aluminum, with an acceleration starting really this year, 2014, and heavily reflected in the 2015 through 2025 data. So we'll talk about that major growth trend, and then some detail about the significant growth market, which is body and body sheet. But we don't want to neglect the fact that there is also continued strength in the other areas of aluminum, the castings and extrusions area. So we'll go into a bit of the component analysis to talk about what's going on there. And then at the conclusion of that, we'll have some time for questions and answers. Just as a little bit of a picture of Ducker, this study was, and I wanted to give you a sense of the scope of this study. This was a 6-month project at Ducker. There are two teams, sort of what I think of as the analytical team and the subjective team. The analytical team actually built a database, it maintains a database, by vehicle, by model, and by approximately 100 different components for each vehicle model combination, where they document the part weights, part materials, and manufacturing processes. That database is about 300,000 elements in it that is used to do the projections you'll be seeing in the next few slides. They also have a team the subjective team that interviews OEMs, suppliers, material producers, researchers in the materials area, and regulators, and tries to develop the concept, the environmental understanding of the decision-making processes that'll be influencing the selection of materials in the future. And it's sort of a bottom-up and top-down view, so they can triangulate on what they believe to be a very accurate assessment, a reasonably accurate assessment of the future. And if past research has been the case, the prior 6 studies, the forecasts have been very, very accurate from our perspective. So this is kind of the macro overview of the trends in aluminum growth since 1975. And this is a report on average pounds per vehicle produced for vehicles in North America. And I should specify, all of this work focuses on vehicles built and produced in North America. So imported vehicles are not included in this data set. But the majority of North American, U.S., Canadian, and American production and Mexican production are in this study. The early days of aluminum, back in the 70s, were predominantly heat exchangers were the growth area. We've grown from about 75 pounds per vehicle in 1975. In 2012, it was 350 pounds per vehicle, and the forecast is looking at somewhere in the order of 547 pounds of aluminum per average vehicle by 2025. Now, the growth in the 90s and through 2010, very significant growth in cast products, particularly engine components, cylinder heads and blocks, and also wheels. Today, cylinder heads are about 98% aluminum. Most of them are aluminum. Engine blocks are at about 85%, wheels are about 65%. Those products are nearing saturation in terms of market potential. They're reaching the maximum the market will be interested in. Hoods started to emerge in the early 2000s, and hoods today are about 48% of the marketplace. And the growth going forward from today out to 2025 is predominantly in body enclosures, hoods, doors, trunks, body in white. And the inflection point on this chart, about 2014, is where we've been growing at about 7 pounds a year increase in aluminum content since 1975. That inflection point at about 2014 starts to grow at about 14. It doubles to about 14 pounds per vehicle per year on average for the next 10 years. Most of that is in sheet and extruded product for body and closure panels. Basically, there's been 40 years of continuous growth, and we anticipate 10 years of even higher rate continuous growth. We're not going to go through all the detail that you'll see in the report that's on our website, but picking off some of the highlights from the conclusions of the 2015 data set, the inflection point that we talked about is in aluminum content per body and sheet is driven largely by a single major program, the Ford F-150 pickup truck, which will be the first all-aluminum-bodied vehicle for high-volume production anywhere in the world. We also have a vision going forward that pickup trucks will contain most of the aluminum in the marketplace, the growth in aluminum, but will be followed closely by E-segment vehicles as well as SUVs and minivans. There's also continued growth in non-body applications, particularly castings and extrusions. We'll talk about that in some detail. Aluminum body enclosure penetration by 2015 will be 6% of the market on a volume basis, a piece-by-piece basis. That's up from less than 1% just a few years ago. And aluminum content in total will be about 10% of the average curb weight of a vehicle. Very significant growth from just a few years ago. Overall market, there'll be almost 7 billion pounds of aluminum products on cars built and assembled in North America. Now, if we look at where the aluminum is used in a vehicle today, just as a spot in 2015 on average, this chart is a distribution of the aluminum by major vehicle component or system. What we see is, if we look at engine components, brakes, heads, and other engine components, about 33% of all the aluminum used in the industry today is in engine components. The next largest group is transmission and driveline components, followed by wheels, and body enclosure is fourth. About 11% of all the aluminum used in 2015 vehicles will be for body enclosures. And that's driven by high hood penetrations in general and the F-150 program. Castings will be 73% in 2015. Now that's down from 82% just a few years ago, and typically running well over 80% for castings. And that's not down because castings are down, it's down because sheet and extrusions are up. And the engines are down from 50% roughly to about 33%, again, because of the penetration in body areas. When we look at where the aluminum is used, and this is similar to conclusions that we have been drawing for a few years, we look at the amount of aluminum used by vehicle segment. In 2015, what we see is the average vehicle content, aluminum content per vehicle is 350 pounds for 2015. What we see is A and B segment vehicles and C segment vehicles are used less than the average content, and typically in these vehicles, the aluminum content resides in the engine, driveline, and wheels. As we look up to larger segment vehicles, D segment, we find a little bit over the average, and in the D segment, we start to see hoods and lift gates and trunks be converted to aluminum. The largest segment of aluminum use is in E segment and pickup vehicles, again, driven by the pickup being driven by the F-150 program. And these vehicles tend to start seeing, will be seeing hoods, doors, trunks, and in some cases, full body in white, as with the pickup truck. Full frame vehicles and E-Series large vehicles are typically where the most aluminum is deployed, and we anticipate that will continue. This is a forecast of vehicle weight, average aluminum per vehicle between today, 2012, and 2025. And what we see is very significant growth in aluminum content for the full-size, full-frame trucks, also for E-Series vehicles. And it's a fairly continuous growth, pretty steady growth between 2012 and 2025. There's continued growth in all segments of the vehicle lineup, but the major growth being in, again, the large and full-frame vehicles. But virtually every segment will see significant growth in aluminum content with introduction of perhaps cradles, subframes, and some limited amount of closure panels on the smaller vehicles. Now we'll take a quick look at 2025 and see where the study predicts we will be going by 2025. So again, 50 years of uninterrupted growth with substantial acceleration in the last 10 years. The main driver, body sheet, clearly body sheet. Also, along with body sheet, we'll be seeing extruded product growth in support of the body structures that will be converted to all aluminum. And by 2025, all body enclosure panels, 26.6% of all panels, including body and white panels, will be aluminum. That's a major growth between now and 2025. 7 out of 10 new pickup trucks produced in North America will be all aluminum bodied. 16% of the curb weight of the average vehicle will be aluminum, and that's a 60% increase from the average curb weight of 10% in 2015. Total aluminum use in the marketplace will be 10.1 billion pounds, or a 37% increase over today's total aluminum consumption. And the non-body applications of aluminum will continue to grow at a steady but reduced rate due in majority to the fact that they're nearing saturation in many of the applications they're in. Now we'll talk about more detail on the emerging growth in the body sheet, particularly body sheet enclosures. Hoods by 2025 are expected to grow to about 85%. Complete body structures are expected to be about 18% of the market, and doors to about 46% of the market. All three very significant growth between now and 2025. So what will this mean to the overall body structure mix of materials used in North America? And if we look at bodies today, and this is body and all closure panels combined, today the average vehicle, 81% is mild or high strength low alloy steel, 18% advanced steels, and 1% aluminum in any form. By 2015, the aluminum will grow to about a little over 6% of the total body construction material. By 2025, it grows to about 26%. Steel still remains the majority material in the body, but aluminum claims a significant share going forward. That growth is fairly continuous, even going back to 2013, 2012 timeframe. It's a steady growth, which includes, in 2015, the large step is the F-150. But if we look at the total trend over a long period of time, there's a very steady growth curve expected for body enclosure volume in aluminum as a percent of the parts in the marketplace. Again, if we look at it by individual componentry, we can see that hoods are the single largest growth area, going from 35% of the market today to about 85% of the market by 2025. The next largest area is doors, which are a fairly low volume, low penetration today, and with the Ford truck will move up to about 6%. Will grow to almost half the market in doors by 2025. And overall, in complete body structures this is the F-150 in 2015, growing to about 18% by 2025. Now, the question always comes up, well, how much aluminum will be needed to support all this growth? And this is the growth curve for aluminum sheet from 2012 out to 2025. In 2012, there was about 200 million pounds of aluminum sheet consumed in the marketplace. That grows to about 4 billion pounds by 2025, and a fairly steady growth rate. The blue material is heat treat stock, 6061, 6000 series typically, and the green is non-heat treat material, typically 5000. So the combined total, about 4 billion pounds almost 4 billion pounds of growth between now and 2025. And the sheet producers are prepared and able to support this growth with the necessary new investments to support this level of demand. So we've said several times the major program in our industry is the Ford F-150, and I thought I'd take a minute just to recap what that program means to the aluminum growth in the North American market. This, to be clear, is in fact an all aluminum body and cargo box, and it will start production the fall of 2014. This is the first high volume all aluminum bodied vehicle ever in the world. Now, this vehicle runs, estimates are about 750,000 vehicles a year. This is the largest program. There's over 1,000 pounds of aluminum on this truck. 680 pounds of that is in the body and structure. The rest is engine, powertrain, driveline, and wheels. When it reaches production, this vehicle will be 25% aluminum, 25% of the curb weight will be aluminum. And overall program, aluminum body, as well as all of the other engineering work as part of the systems engineering, this vehicle will be approximately 700 pounds lighter than its predecessor and the same size with equal or superior safety performance. And we've heard reports of significant improvements in handling, braking performance, and the fuel economy improvement has not been reported yet, but we're anticipating a very significant fuel economy boost for this vehicle. If we look at the shift in material forms that will be required to meet this growth curve in the auto industry, what we see is a significant shift from, in 2012, automotive castings represented roughly 80% of all the aluminum consumed in the auto industry. Sheet and plate were all fairly minor, and extrusions were fairly minor portions of the total market. If we move out to 2025, castings are reduced to about 59% of the market, and sheet becomes about 30% of all the material consumed in aluminum in the auto industry. Mill products, which is flat roll sheet as well as extrusions, grow from about 18% of the total to 41, over double the amount of, on a pounds basis, the amount of aluminum material for those product forms. So significant shift away from castings, although I need to point out castings don't go down in volume, in pounds. They remain fairly flat with slight growth. The big impact is the high penetration of new sheet products. That'll be the end of our comments on sheet, and just so we don't lose track of the fact that the casting and extrusion businesses in aluminum are alive and well, and also part of the support necessary to meet industry growth between now and 2025 and beyond. We have a lot of extruded product. Subframes will reach 25% share of the market by 2025. Aluminum blocks will remain around 85%, we feel, and wheels up to about 75% of the market from about 65 now. Wheels have been between 65 and 75% of the aluminum market for the last 25 years. That's about the balance point for the demand on aluminum wheels. Again, this is where the aluminum is used in a vehicle. We're looking at the bottom four items are all engine. That's the largest single area. This is 2015. This is sort of a recap of where the aluminum goes. Driveline is number 2. Wheels is number 3. Body, number 4. If we look at where those systems are going between now and 2025, what we see is virtually all of the segments are stable or growing with the market, with the increased sales of vehicles. The significant engine parts, pretty flat. Some decline in engines due to the downsizing being made possible by higher engine technology, allowing smaller engines, and lighter vehicles allowing smaller engines. So The number of pieces remains the same, but engine blocks particularly may go from 8 to 6 and 6 to 4. So there's somewhat of a decline there. What we see is driveline fairly flat. Some growth in transmissions with the larger transmission number of gears in the transmissions. Most everything fairly flat. Some growth in wheels and significant growth in steering knuckles. But the overall major growth is again in the body area. Looking at castings in specific, it'll tell us a little bit about where where the growth is coming. We see some growth in the sand, mostly permanent mold, and this is largely suspension components, knuckles, and those ride and handling type pieces. Fairly flat in the high pressure die casting, significant volume, and we start to see the emergence of vacuum die castings, and those are very important elements going forward for auto, aluminum, or steel body structures. And most of this is in the suspension towers for future vehicle structures. Significant actual growth in that segment of the market. On the extruded products area, we see very significant growth in both shapes and tube. The majority of that growth is also for body structures. We're seeing fairly high content of aluminum extrusions in the support structures and energy management systems in future vehicles, particularly the all-aluminum vehicles. In terms of body extrusions, gross body shapes and tube for extrusions, again, very steady growth between now and 2025, driven by the adaptation of aluminum to body structures going forward. So in summary, and we'll handle any questions we want to cover later, it seems very clear that the multi-material approach to future vehicle design is solidly present in the marketplace going forward. The complex demands that are being made on current and future automobiles require OEMs and every one of us in the industry to take an aggressive look at deployment of the right material in the right place and open up the arena to a variety of competing materials. We see the smaller vehicles, potentially the lighter vehicles with predominantly steel, with some aluminum closures and other elements in the body. The mid-range vehicles seeing a mix of steel and aluminum, body in white versus closures again. And large vehicles seeing a shift to very significant content in aluminum body and closure panel. Very significant shift. Automakers will continue to increase the use of aluminum, and it'll be up to about 16% by 2025. Very significant growth. And the growth rate at 14 pounds a year is actually the largest sustained growth rate the aluminum industry has dealt with in the auto industry. We've had 14-pound a year growth rates in the past, but not for 10 years in a row. So we're forecasting the longest period of sustained growth in our history. And clearly the emerging applications, the focus is absolutely body enclosures, with growing up to about 26% of the market. More than 1/4 of all the panels will be aluminum by 2025. And the body structure total, the body in white, grows up to about 18%. That's the real frontier for our industry. And it's pretty clear that the unique engineering attributes of aluminum make it a very attractive material in many of the challenging environments that future vehicles that we're all part of are going to have to deliver results to consumers. And with that, I'd talk more about the future. I'll turn this back over to Tom Boney.
Hey, thanks, Doug. That was great. Appreciate the going through that rather comprehensive presentation for everybody. This next slide is what's next, and it's what does this survey of the Automakers conducted by Ducker tell us what's coming down the road, and here are some conclusions from the ATG, and the Aluminum Association, the automobile manufacturers are continuing to strive to build a better and better vehicle every year. And aluminum is helping to build that better car. And its value proposition to the automobile manufacturers is a fast-growing phenomenon. Due to its performance, efficiency, sustainability, safety, and durability advantage, auto aluminum is at an all-time high, and this survey confirms its use to expect to increase rather dramatically, exponentially, by 2025. Let me be clear, though. We are absolutely steadfast that this is a multi-material world, that there is no future of a single material that will dominate the entire industry as it has in the past. I think we're going to see a continuation of developments and progress at a multiple levels, and aluminum will participate in that. And high-volume aluminum-bodied vehicles are headed to showrooms in the near future, and that bodes well for consumers, the auto industry, and for the environment. And in this last slide, which came from the Detroit Free Press on July 13th, I thought the headline or the first sentence was too rich to pass up because of some of the irony. Aluminum is closing in on the silver bullet status for the auto industry. Well, it's interesting, aluminum is now being silver. I'd rather call it the aluminum bullet. But that being said, the future to where we are today is 50 years of continuous innovation, continuous development, work and collaborative work between a variety of different entities to allow aluminum to get to the point where we are today. And we're at an inflection point, and we're only getting started to the next phase of what will be solving many of the consumers' needs and requirements for years to come. So I think that brings us to the end of our formal presentation. I'll turn it back over to our facilitator, who can help us with regard to the Q&A discussion. And we're also at this stage going to invite Dick Schultz, as Doug had introduced him earlier, to participate in any of the technical questions associated with the way the survey was conducted or its presentation of its facts. So with that.
As a reminder, you can submit your questions in the questions box at any time. Okay, we have our first question. We've actually received this question from a few people. How does the current 2025 aluminum content per vehicle forecast differ from the prior Ducker forecast?
Well, I think there's no better person to answer that than our good friend Dick Schultz, who's been around for many of those prior Ducker studies.
The gross numbers look similar, but there are numerous details inside the work that really components such as doors and the high penetration of hoods and the 18% body structure. We did not have that level of detail when we did the 2012 study. We based the 2012 study on much more of a top-down analysis of what we thought would be needed for the OEMs to save about 400 pounds of weight on average per vehicle by 2025 over the 2012 number for total weight or curb weight of the vehicles. This time, we did a much more bottoms-up analysis. We had enough information to go out and actually talk with the OEMs about specific programs. Much of that was in confidence, but we were able to combine the numbers and come up with the forecast. So it's really more in the credibility of the numbers compared to 2012 than the actual number itself. We have expanded our database by hundreds of thousands of cells this time around to add all the doors and fenders and lift gates and tailgates and hoods and body structure parts, as well as vacuum die-cast parts, as well as several extruded components in the subframes and other components other than the body. And so when we did all of that, we have much more confidence in this study, and there's much more detail behind it than the study we did in 2012. But it also confirms our top-down analysis at that point that the OEMs are on track to try to remove about 400 pounds on average from the overall vehicles, and maybe 800 pounds, as much as 800 pounds in pickup trucks and large SUVs. And this is being confirmed by the details behind the study this time. So it just adds a much more high level of detail and much more confidence in the numbers than we had in 2012. But the market's sort of unfolding just the way we had predicted 3 years ago.
Dick, I think you should mention that the 2012 forecast for 2025 was 550 pounds, and this one is 557.
And they're really two different matrices and databases and two different studies, but it just tells us that we're on the right track, and 400 pounds, which is essentially what the EPA is forecasting for weight savings, is coming to pass.
Okay, we have our next question. Are there any issues in multi-material vehicles in terms of galvanic corrosion or other potential issues?
Doug, why don't you go ahead and take that?
Sure. There are issues. Like any engineering challenge, there are accommodations that have to be made. Typically, the aluminum structures are put together with adhesives now. There's at least adhesive sealants, and they do a very good job of isolating from the galvanic corrosion issue. And then, of course, the ELPO tends to seal. If we're talking a whole body structure, then the ELPO tends to seal the entire structure. A lot of the aluminum panels that are attached to one another are attached with steel fasteners, either self-piercing rivets or flow screws, those kinds of things, and they are already coated. And so far, we have not seen. These have been in use for over 10 years, mostly in Europe. There have not been any significant issues since those technologies have been introduced. So, yes, it has to be thought out, and there are readily available solutions that are in significant high-volume applications and pretty well proven in the marketplace.
Thanks, Doug.
Okay, we have our next question. On the graph of change in use of aluminum per vehicle components from 2012 to 2025, why does the control arm and link component decrease and then increase back to 2012 levels in 2025?
Well, the primary reason is that, just as both of the other speakers have reinforced, this is a multi-material analysis in many ways, because we had to look at steel to figure out what was going to happen with aluminum. And the steel industry has come up with some very unique designs for what they call clamshell control arms, where they take two pieces of dual-phase steel, make a stamping, and then clamshell it together so it's hollow inside. And that, at least currently, is competing more effectively than any past solution with cast and forged aluminum control arms. But we are finding out that there are some limitations to that particular design, and so we, at least for now, have tempered our forecast for control arms as a aluminum solution that's going to reach 25 or 50% penetration. But there are going to be a lot of designs, particularly with the Japanese OEMs, that will remain in forged aluminum. Mercedes, BMW, Volkswagen also use the forged aluminum design. And when you add up all the numbers, we've tempered our growth, but it does come back to life to some degree over the next few years, but nothing like we had forecast in the past. So this just, again, reinforces the fact that these are multi-material solutions. Steel parts are going to come and go. Even some aluminum parts are going to come and go as the engineers get better and better at using the multi-material solution. And you can't fight the tape. This is the way. These are the answers we got in our discussions with the OEMs, and that's what's portrayed on the chart. But it really isn't a big dramatic change in the later years. It looks like it, by the looks of the chart, it's kind of gets back to where it is now by 2025, maybe a little bit higher.
Our next question is, where exactly does the growth in permanent mold castings come from?
Dick, do you want to handle that one as well?
Yes, I think you alluded to it, Doug. One, of course, there is some continued wheel penetration. And the second point is that there is quite a bit of steering knuckle growth. There is some, talk about multi-materials. There are some ductile iron solutions that are quite attractive. But overall, as we talk to the OEMs, they all have very large penetration plans for aluminum steering knuckles, particularly made by the VRC-PRC process, which is a form of permanent mold. So it's primarily the knuckles and some increased penetration of aluminum wheels, both of which require permanent mold rather than high-pressure die cast or sand cast solutions.
Our next question is, does this take into account any lost volume for current aluminum components that may shift to other materials such as carbon fiber?
In this case, we did, we really had a lot of discussions with carbon fiber, and in our math study, in the study that only goes to the association, I think we have about 20 pages in there of things we uncovered on carbon fiber. But between now and 2025, there just is the cost curve for carbon fiber composites is just not going to decline enough for any kind of high volume use in North America and even in Europe. If we looked at 50 years or 30 years maybe even, I think we will see more penetration of carbon fiber, but not by 2025. This forecast does include some increased penetration of magnesium parts, competing with some of the cast aluminum parts, particularly in the transmission applications, transfer applications. In fact, the new F-150 was converted from an aluminum transfer case to a high-pressure die-cast magnesium case. So there is some increased penetration of magnesium components, but there is no significant use of carbon fiber composites in this study. There's just not enough time to get the cost down enough for solutions to be engineered in by the end of the decade to affect 2025.
Our next question is, do you see the pace of change for manufacturers outpacing the ability of repairers to keep up with the training and tooling due to the lack of incoming technicians in the industry?
I'll take that one. What I'm seeing, and I'm seeing it firsthand, is that the repair industry is really aggressively addressing the shift in materials in the auto body. And there's some conferences. There's organizations that have already organized very extensive training and certification practices for technicians in new vehicle structures, and the entrepreneurs that run the independent shops are really getting their thoughts together on how and when they will conduct the training. And right now, the marketplace isn't confronting them with a lot of these aluminum repair opportunities, but they foresee it, and I'd say they are committed to being in place and ready when the volume is out there to be serviced. So I think that's not going to be a constraint.
Our next question is, if mainstream vehicles like the F-150 go aluminum intensive, how do premium luxury high-performance vehicles differentiate themselves with the use of aluminum?
I'll take that one. The automobile manufacturers and their branding is owned by those companies. They've figured out how to brand their own performance characteristics on a variety of different attributes, and I think that question is best answered by the automobile manufacturers. It's the good thing about this, the really exciting thing about what the question really leads to is historically the advantages of aluminum to the performance of a vehicle has been domiciled to the high-end luxury vehicles. And now for the first time, we're really getting to see a more mainstream opportunity to take advantages of those same incredible performance characteristics. And that's exciting. I mean, that's technological advancement that's bringing better technology to a very large group of people. And so, we're just thrilled to be part of that step in that direction. The branding will lead to the automobile manufacturers.
Tom, if I could add, in certainly very high-end vehicles and sports cars, aluminum has been used to help improve the 0 to 60 time because it's very valuable in the marketplace for Corvettes and a variety of high-end sports cars and luxury cars. Now the industry is turning to using more aluminum to not increase 0 to 60 time, but to actually take weight out to improve fuel economy and reduce CO2 emissions. And so it really is the difference in the philosophy of the marketing teams for a Corvette versus the marketing and design teams for something like an F-150 or a large SUV. So sports cars will still be sports cars, and they'll still be going, so they're going to have really low 0 to 60 time tests, but the majority of the market is going to adopt aluminum to, again, reduce weight, reduce engine size, and lower CO2 emissions.
Our next question is, how many OEMs were surveyed for this study?
All of them. I can't think of anybody we didn't talk with in an engineering sense. In fact, my team's even meeting with Hyundai today on some discussions. So we had to approach all the OEMs and talk to them about what they saw developing on the material side. And there were some differences from OEM to OEM. Certainly Mercedes' philosophy might be a little different than Subaru's philosophy, but all of them are programming in much more aluminum use, as well as converting some of their mild and HSLA steels to dual-phase steels, and even maybe a few of the over 1,000 megapascal steels. So to get the 400 pounds out, they all know that's the target for the average vehicle, and they're all working feverishly to take out the 400 pounds. And we confirmed that by discussions with every OEM that makes vehicles in North America.
Our next question is, how does aluminum impact vehicle safety?
Well, what we've seen in a number of programs, and I think a fair statement would be that it's equal to or better than any alternatives that are evaluated. The key in vehicle safety is actually the design of the structure itself, regardless of the material. We've seen just amazing technological advancement in virtually all of the OEMs on how to engineer a structure for safety. And in some cases, we found that the superior energy absorption capacity of aluminum, the ability to deform and not buckle, has been used constructively to enhance the safety performance of the structure. Many bumper collision cans or crash cans are aluminum. We produce a lot of those, and again, capitalizing on the energy absorption characteristics of the aluminum. So, but every structure I've been a part of, and I think most of us in this industry have been a part of, every structure in all aluminum is, in fact, significantly better in collision performance than the prior structure it replaced. But I hesitate to point to the material alone as the difference. I think the major difference is the skills of the engineering organizations designing those structures and their ability to learn over time and make a better structure every time they get an opportunity to do it. So, but there certainly hasn't been any degradation of safety performance on any of the programs that have gotten into volume production, although they were low volume programs.
The OEMs wouldn't dare to put out a vehicle that had reduced safety from where they are today. And as Doug points out, 99% of the time they put out a vehicle that is even safer than the vehicle it replaces. So we have to rely on the OEM engineers and their dedication to producing the safest, most fuel economy achieved vehicles the world has ever seen.
Yeah, and just one last point on that. One of the key drivers that we highlighted early in the presentation was the fact that the OEMs for the North American market want to retain the size of the vehicle. And by retaining the size of the vehicle and making it lighter weight, the size is a big impactor of the safety of the vehicle on the road. So rather than downsizing to get higher fuel efficiency, the size of the vehicle will remain the same. It'll just be a lighter weight vehicle, which provides great protection to the driver.
Yes, Tom, the average footprint, which is the best measure of size of a vehicle, was 49 square feet in 2008, which is the base year for NHTSA and the EPA for their movement going forward to reduce CO2. And they are working feverishly in terms of the way they structure the regulations to keep the average footprint of all the vehicles at an average of 49 square feet by 2025. And this is mainly for safety reasons. And so reducing the footprint of the vehicles is just not one of the arrows in the OEM's quiver to meet the 2025 mandates.
And this will be our final question. Are automakers considering the life cycle assessment on aluminum as a factor to use and embrace aluminum?
You know, the Aluminum Association has been actively involved, and we've talked about life cycle assessments, and clearly there is a discussion around life cycle assessments that's a very deep and very interesting conversation, and that no one, I think, is fundamentally ignoring. But the driver to this report and what Dick will tell you to the dramatic growth is not as much directed towards the life cycle assessment that has a factor, but has to do with regard to the socioeconomic drivers out there that are associated with people wanting better fuel efficiency, safer, higher efficiency, better performing vehicles than what they've had in the past. And those consumer requirements, the people that feel tangible and feel good about what they actually pay for and what they really understand, is what's really driving and motivating this dramatic change that we see happening over the next several years. Dick, I don't know if you want to add to that.
Well, you know, in terms of the life cycle, I mean, Doug is an expert in this, but all the studies we look at, and we've been rather neutral in these, they're really based on end-of-life recycling, where the data shows that you're going to get back almost every pound of aluminum and every pound of steel that's in that end-of-life vehicle. One of the exciting things about the aluminum proposition is that there's a lot of closed-loop recycling that's going to occur in the stamping plants. That does not actually get factored into the calculation of life cycle analysis, because it really gives you credits for end of life, not necessarily beginning of life unless you crash the vehicle. But from an environmental standpoint, it can't be denied that all of this closed-loop recycling of aluminum stamping scrap from the stampers in the automotive industry is really a tremendous environmental story in terms of scrap being reprocessed, made back into hoods and doors and other parts in aluminum, you know, a few months after it was first stamped as off-fall in the stamping plant. So, at least from my perspective, although it doesn't enter into the calculation, I think the closed-loop recycling of aluminum scrap, which is not done in steel. Most of the steel scrap gets sent to a junkyard and gets made into rebar rod, that type of thing. But in the case of aluminum, like the aluminum can, the scrap will actually be made back into the same alloys that are used to make the original stampings. And so that's an environmental story that really we haven't stressed enough, but it will be stressed going forward.
We'd like to thank everyone for their participation today, and for the webinar replay and for more information on auto aluminum, please visit drivealuminum.org.